Hello guys, welcome again to my channel. Today here comes a nice exponential challenge which reads x to the power of 6 is equals to 9 to the power of x. We are looking for the possible value for x. So please, if you are new here, kindly subscribe to this channel and please don't forget to turn on the notification button so that you get notified whenever I drop videos on mathematics. So let's see how we can solve this. Okay, I'm going to apply two methods in solving this. The first method will be very familiar to you, but the second method, I believe it might not be familiar. So the first method is this. I'm just going to apply the direct principle of mathematics. While the second method, I'm going to apply what we call the Lambert W function. In other words, we can solve this using the direct mathematical method and also solving this with the Lambert W function. So let's see for the first method. So I can say method 1. So solution first. Okay, and method 1. Okay, so we can write the question which reads x to the power of 6 is equals to 9 to the power of x. The first method is very easy. So the first thing I can do is to remove x at this right hand side. So if I should do that, I can have this to x to the power of 6 open bracket to the power of 1 over x is equals to 9 to the power of x open bracket or to the power of 1 over x. So you see what I'm doing. Okay, having this. From a simple mathematical rule which says if you are having a to the power of b or to the power of 1 over c is equals to a to the power of b over c. So if I should put this through here and here, I can have this to be x to the power of 6 over x. Okay, equals to 9 to the power of x over x. Okay, to the power of 1 to the power of 1. Okay, you cannot see that this x and this x will go. What are we now left with? We are left with x to the power of 6 over x is equals to 9 to the power of 1. So the next thing I'm going to do is to remove this 6. So if I want to remove this 6, I will take the power of 1 to 6. So if I should do that, I'm saying x to the power of 6 over x or to the power of 1 over 6. Okay, equals to 9 or to the power of 1 over 6. Okay, having done this, I can put in this, applying this principle again. So if I'm doing that, I will have this to be x to the power of 6 over 6 times x, okay, equals to 9 to the power of 1 over 6. Okay, so this and this will go. What are we now left with? We are left with x to the power of 1 over x, okay, equals to 9 to the power of 1 over 6. Recall, I can rewrite 9 is also equals to 3 to the power of 2. Okay, so I can have this to be x to the power of 1 over x is equals to 3 to the power of 2 times 1 over 6. So having done this, I can say x to the power of 1 over x is equals to, so 2 here 1, 2 here 3, which is also equals to 3 to the power of 1 over 3. So I can say x to the power of 1 over x equals to 3 to the power of 1 over 3. So by comparison, my x is equals to 3. So this is for the first method. So let's try out the second method using the Lambert W function. Let's move on. Okay, so to apply the first method, we apply the first method and we arrive at what x is equals to 3, right? So this is the question, x to the power of 6 is equals to 9 to the power of x, and we are looking for the possible value for x. And we apply the first method and we got x is equals to 3. Now we want to apply the second method, which is the Lambert W function method, to see whether we are going to have the same value for x. So if I say solution, so at this juncture, what am I going to write? I can write method 2. So method 2. Okay, then I write the question which says x to the power of 6 is equals to 9 to the power of x. Okay, so the first thing I'm going to do is to multiply both sides of the equation with a natural log. So if I should do that, I'm having ln x to 6 is equals to ln 9 to x. So recall from a basic principle of logarithm, if we are having ln of a to c, it's also equals to c ln a. So if I should put this principle here and here, I will have this to be 6 ln x is equals to x ln 9. Okay, having done this, okay, let's make s stand one side and let's make numerical value stand at the other side. So if we should do that, we are having ln x over x is equals to ln 9 over 6. Okay, having done this, what then is the next step? Okay, we can rewrite 9 again. Recall we say 9 is equals to 3 to the power of 2. Okay, so we can say ln x over x is equals to ln of 3 to the power of 2 over 6. Okay, we can say ln x over x is equals to 2 ln 3, okay, over 6. So having done this, we can say 2 here 1, 2 here 3. Okay, we can say ln x over x is equals to ln 3 over 3. Okay, now this is what we are not having. From here we can easily solve. Then we can say x is equals to 3 and ln will cancel off ln, then we'll say x is equals to 3. But let's simplify this more. Okay, for the sake of if these numbers are not the same, provided that assuming that we are not having x is equals to 9 and assuming that x is here and we are having 6 here and we are having 3 here, we cannot just easily compare. So let's solve further to see whether x is equals to 3, because from here we can easily compare. So if I'm having this, if I'm not having this, I can write x is equals to exponent ln x, because this exponent will cancel this ln. So if we should do that, we are having ln x over exponent ln x equals to ln 3 over, so the same thing for 3, and 3 is also equals to exponent ln 3. Okay, so wherever I see there, I can put exponent ln 3. Okay, having done this, I can bring this to the top, So if I should do that, I'm having ln x times exponent ln x to negative 1 equals to ln 3 times exponent of ln 3 to negative 1. Okay, so recall this one will be coming to the back, then this one will be coming to the back. So if I should do that, I'm having this to be ln of x exponent of negative ln of x equals to ln of 3 exponent of negative ln of 3. Okay, exponent of negative ln of 3. So if I'm not having this, I can apply the Lambert W function now, but it's not still yet correct, because the Lambert W function says if we are having star exponential star, we should take the Lambert W function of it is equals to star. So we are using star, not x. Okay, so we can see that at this exponent we are having a negative value, but at this base we are having a positive value. At this exponent we are having a negative value, at this base we are having a positive value. So what are we simply going to do to make them look similar is to multiply both sides of the equation with a negative sign. So if we do that, we are having negative ln x exponential negative ln x is equals to negative ln 3 exponential negative ln 3. So you can see that this base is not the same as the exponent. This base is not the same as the exponent. So if we should take the Lambert W function of it, Lambert W function of ln of x exponential negative ln of x close bracket is equals to the Lambert W function of negative ln of 3 exponential negative ln of 3 close brackets. Okay, we should do this. So we are now having negative ln x is equals to negative ln 3. So this negative sign will cancel off this negative sign. Okay, we're now having ln x equals to ln 3. So this ln will cancel off this ln. So we're now having x is equals to 3. So this is the value for x. This is the value for x. So if you find this video useful and interesting, please click on the subscription button and turn on the notification bell so that you get notified anytime I drop videos on mathematics. And also please don't forget to hit on the thumbs up button. Bye for now, and see you in my subsequent video. Bye bye.